Hello students, good evening and welcome to my channel Physics Destination. Let's fall in love with physics. In today's class, I will take the Ampere circuit law. Why I have selected this topic in today's class? First reason, this is very much interesting. Second thing, this is very much important law. That's why you have to study. You must have to study this Ampere circuit law. Ampere circuital law. So ma'am, why to study this Ampere circuit law? To find out the magnetic field across the current carrying conductor. Suppose if it is a current carrying conductor, current I is flowing in this, then there must be some magnetic field generating around the conductor. To find out how much magnetic field is appearing, how much magnetic field is generating across the conductor, we will study the Ampere circuit law. Got it? So you might have thinking that in Biot-Savart law also we will find out the magnetic field. Then why we need the Ampere circuit law to find out the magnetic field? You might have think, but the reason is there are some similarities and some differences between the Ampere circuit law and Biot-Savart law. In Biot-Savart law also we will find out the magnetic field. In Ampere circuit law also we will find out the magnetic field. These are the similarities. What about the differences? Here in Biot-Savart law we will find out the magnetic field by differential form. In the Ampere circuit law there is a integral form. Okay, in both the cases we will find out the magnetic field. So let's move to the Ampere circuit law. I will start the statement first. जब आप कोई भी लॉ पढ़ते हैं तो उसका स्टेटमेंट जानना बहुत ज़रूरी है, ठीक है. देन व्हाट इज़ द स्टेटमेंट? आई विल राइट द स्टेटमेंट. याद रहे एम्पियर सर्किट लॉ में हम मैग्नेटिक फील्ड को पता करेंगे, ठीक है. बट द कंडीशन इज यहाँ पे मस्ट एंड शुड क्लोज लूप होना चाहिए, ठीक है. आपको दो कंडीशंस याद रखना है. एंड लेट्स मूव टू दिस स्टेटमेंट फर्स्ट. Statement is line integral of a magnetic field is equal to the product of the algebraic sum of current. Line integral of magnetic field is equal to the mu naught and algebraic sum of current. If I write this statement in the form of mathematical equation, then you will get closed integral. You have to write the closed integral. Magnetic field is equal to the sum of algebraic current, okay, and mu naught. Here you have to write the mu naught. This is the most important equation you study the Ampere circuital law. Okay, we will discuss about this equation in details. So here is the statement. You can take the screenshot and then we will prove the equations. Okay. Suppose I have a current carrying conductor of infinite length. How do you know this length is infinite? Because here I have drawn dots, here also I have drawn. It means the length is infinite. The current I is flowing in this conductor. Okay. At this point I have to find out the magnetic field. Let the distance be r. Okay. So now what I will do? I will draw the closed loop. Here one thing you have to keep in your mind that if you take the element dl, if anywhere you take the element dl, in the entire sphere the magnetic field is equal. Okay, this thing you should have to remember. So at any position of the sphere the magnetic field is equal. So according to the statement, what is statement? Magnetic field B dot dl is equal to mu naught algebraic sum of I. Clear? So this loop is called Ampere's loop. Okay, what is called Ampere's loop? So here phi into magnetic field B into dl is equal to mu naught. Here the question comes, what is this? Sigma into I. The algebraic sum of current is equal to I. Why it is I? Because in the circuit the single current is flowing. That is why the algebraic sum sigma I is equal to I. Okay, here instead of sigma I you can write the I. This much clear? Next, phi is equal to B. If I have to remove this dot product, then I have to write cos theta. B dl into cos theta is equal to mu naught into I. Next, say phi B dl. What is this cos theta? Here you can see the value of theta is 0. Why? The magnetic field is perpendicular to this point. Alright, so theta is equal to 0. Cos 0 is equal to 1. You know this from earlier classes. Cos 0 is equal to 1. Here 1 is equal to mu naught into I. Next, B into, instead of dl, can I write 2 pi r? Of course, I can write 2 pi r. This is equal to mu naught into I. After the simplification, I will write B is equal to mu naught divided into I divided by 2 pi r. This is the very important equation to find out the magnetic field. Okay, so this is the simple, very much simple Ampere circuital law. Okay, so in this Ampere circuit law I have found out the magnetic field in the closed loop. Condition is, I have told the condition, there is must and should be a closed loop. Okay, so this is the equation. I hope all of you have understand the Ampere circuital law. If you have any doubt, you can ask me in the comment box, and if you like my video, please share and subscribe. Thank you very much.